Okay, let's start section 5.3, which is about proving triangles congruence by SAS. Now, what is SAS? That means side angle side. So we're really going to just get into diving into proving two triangles to be congruent by using that theorem or method. Remember, congruent figures, those are figures that have the same angles and the same side lengths. So in this instance, we're talking about two triangles with the same angles and same side lengths, or congruent side lengths and angles. Don't forget, once again, when you take a triangle or any figure right here, when we talk about rigid motion is when the side and angles are the same. Or if I take something like this, which is actually rectangular in shape, no matter if I turn it, slide, glide, whatever, the angles stay the same. All right, and so do the side lengths. So let's go ahead and get down to side angle side, and what is that all about? So in theorem 5.5, it states that if two sides and an included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. So big thing right here is take a look at this triangle ABC. It shows that we have two congruent sides, okay? That's great. That is important. However, what's even more critical than that is that, remember, it's saying that it has to be two sides, and then the included angle. So if you forget what the included angle is, it's the angle that's going to be in between those two sides. So therefore, angle A is between side AB and side AC. If we take a look on the triangle it is congruent to, we can say that it's congruent to triangle E or DEF, because if you take a look, we have two congruent sides, and angle D is the included angle. So we can go ahead and say that, look, AB is congruent to segment DE. Angle A is congruent to angle D, and side AC or segment AC is congruent to segment DF. And therefore, we can go ahead and say that these two triangles are congruent. So in our proof today, you must be able to prove two sides and included angle to be congruent. Okay? If you cannot do that, then the triangles are not congruent. So let's show you how we're going to do that right here. Let's take a look at number 1. All right, so I have two triangles here. Well, actually 3 if you look at it. We have the two small ones on the inside and the whole thing as the third. Well, what can we go ahead and start off with? Remember, it always helps to probably use the figure, draw things out, and remember, in a proof, you always want to start with the given. So let's go ahead and start with the given here. Try to put this together. All right, there we go. So I'll start with 1. And remember, when you guys are doing your proofs, write them down. Make sure that there are 2 columns. What's given? It says up at the top, we got segment BD as perpendicular to segment AC. We also have AD is congruent to CD. So we're going to go ahead and put all that down. In step 1, that is given. All right. So if BD is perpendicular to AC, right? What that tells me is that I have 2 angles that are 90 degrees. So despite the fact that they told me that they're congruent, I have to add to my proof that we have 2 angles that are congruent. So that's why number 2, let's go ahead right here, and I want to go ahead and say that angle AD is congruent to angle CDB. Now, once again, you got to be careful with how you arrange the letters. It is important in talking about sides and angles that are congruent. So ADB, I went from the outside to the 90 degree to the up top. So I have to do the same thing with this other side right here. I start with angle C, drop down to the 90 degree angle, and then up to the top where B is. So we have to give a reason. Why are they congruent? Well, we can go ahead and say right here, one of them is that we got the linear pair perpendicular theorem. Right? If I have two angles that are 90 degrees, then they add up to 180. And if they're perpendicular, they both have to be 90. So therefore, I know that those two angles are congruent to one another. So now, I know that a pair of sides are congruent, right? AD and CD. I know we have a pair of angles to be congruent right here. So if you think about it, remember, it has to be the included side. That side right here that looks to be, that needs to be proved and used is this one right here from B to D. So how am I going to prove that these two triangles have that same side? That's where we go back and think about what we learned in chapter 3 and chapter 4. And first off, I want to go ahead and state that BD, segment BD, is congruent to segment BD. Give you another moment to think about it. Why would they be congruent? When on both sides of our congruent sign, it's the same. Hopefully it rings a bell. We've got ourselves our reflexive property. And remember, reflexive property applies to angles. It also applies to segments, right? And also with real numbers. So we got a reflexive property of congruence. So now that I have right here a side, an angle, and a side to be congruent, then I can go ahead and end the proof and say that triangle ABD is congruent to triangle CBD, and we'll call it side angle side. And there you go. Just that easy, right? Proofs. We've been doing it for a few chapters. Now we're putting it all together. Let's take a look next up at number 2. All right. Well, let's see here. We are trying to prove, let's first off, there's a lot of triangles, so let's see, what are we trying to prove? That triangle J and K. Okay, this triangle right here. J and K is congruent to triangle M and L. So those are the two triangles that I do want to focus on. They give us some information, all right? Let's see what we have that's given here. We have JN is congruent to MN. Great. We have one pair of sides congruent. We have NK is congruent to NL. Excellent. So those two things are congruent, and you can see on the diagram how they have the little hash marks there. So we'll go ahead and put right here that it is given. Sorry for my handwriting. I know it's not always great, but it doesn't help the fact that I've got this, what do you call it, a wrap on it at the moment. I had surgery, trigger finger. In case you're wondering, it is feeling better. Hopefully I could take this thing off in another week. All right, so moving along. We have two sides that are congruent. Now, if I'm going to prove using side angle side, hopefully I look at these two sides, and this angle N right here would be the included angle. Or we can't just say N because angle N could be many things. be more specific, angle J and K. Well, it looks to me that angle J and K is congruent to angle N and L. So that's what I'm going to go ahead and put for number 2. Angle J and K is congruent to angle M and L. You got to give a reason for it. We have 2 lines right here, NK or segment NK, MK, and segment JL. Those are straight lines, essentially. And they intersected and they form these 2 angles, or actually 4. Well, what are those 2 angles? The relationship? That'll be the reason. And our reason here, hopefully you got it down, that is your reflexive property. Or sorry, looking at the wrong thing right here. That's all about vertical angles. Are congruent. I think from chapter 2 we covered that one. And so now that I have my side, I've got my angle right here and another side that are congruent, then I can go ahead and say that triangle J and K is congruent to triangle M and L. And that right there, we can go ahead and say we got our side angle side congruence. Moving along, let's take a look at number 3. So it says, use the information and name 2 triangles that are congruent and explain your reasoning. I want you to treat this like a proof, okay? Think, well, what 2 triangles can we say are congruent? Give you a moment, maybe you could press pause, kind of think about it. But we have a big thing here. Remember, we have ourselves a circle. I've got 2 triangles. Look right here, P to G. Well, what is P to G? I've got P to H. What exactly is P to H? I've got P to F right here as well. And then I also have P to E. What are those segments? We have a circle, we've got segments. P is at the center. Check this out. These are all radii. Right, from the middle, from the center to the outer part of the circle, that's your radius. So we've got radii here, and that tells us that we have sides that are congruent. Right, so I can go ahead and say right here, like EP, if we were to treat this like a proof, EP is congruent to, let's say, HP. And FP is congruent to GP. Right? All of these, the reason why they're congruent is because we have a property of a radius. Right? Or definition of a radius. We go ahead and say that. We have 2 angles that are congruent. I know that right here, angle EPF is congruent to angle GPH. And, you know, that right there is given. So then we can go ahead and say that right here, triangle let's go ahead and put triangle EPF is congruent to triangle HPG. And we can go ahead and put right here, side angle side. All right, next up, we got ourselves, we're trying to explain right here. We know that this hexagon, ABCDEF, is a regular hexagon. Okay, so that's great. Let's see what 2 triangles we can go ahead and prove to be congruent. I look right here. Remember, if I know that a side is congruent, then there's one. We got all sides around the outside to be congruent. And so we know that AF is congruent to ED. All right, AF is congruent to ED. All right, so that's one part of our triangle. If we look right here, let's see, what else can we say? We've got the length of E to B to E right here. That goes straight through across and through the center. And so does this right here, C to F. All right, we can go ahead and say that that right there is that they're congruent as well. And we have that B to D and C to A right there will be congruent. I'd say this one's probably not the best one to explain. I take a look at this and I don't like question number 4. So we'll go ahead and kind of move along from there. But one thing to know, remember, in a regular hexagon, all sides and all angles in the interior and the exterior should be congruent. Let's take a look at the last one, number 5. This one's actually a good one. So quilt is made of triangles, and they're telling us that segment PS and QR are parallel. Okay, so PS and QR are parallel. They also tell us that PS right here is congruent to QR. And we're trying to use side angle side, all right, to prove that PQR is congruent to RSP. Okay, so let's try right here. We're going to go ahead and prove that PQR, so this triangle right here in green is congruent to RSP. All right, so let's go ahead right here. Statement 1, let's put what's given. PS is congruent to QR. That's in the statement above, given. What else do I know? Okay, well, we have to remember that we need to include another side. Well, if I look right here at the diagram, I could see that in both triangles, right there, there's red and blue on the diagonal of the triangle. So we can go ahead and say that PR, remember this is like one of the statements we had earlier on, and we can go ahead and put right here, PR is congruent to PR. Because both of the triangles have that same side. And when we do that, we'll go ahead and put right here, reflexive property. Reflexive property of congruence. All right, so what else can I say? We have to have an angle. Now there's 2 different ways we can go about this next part. But what I can say right here is this. Remember, they told us that we have 2 lines that are parallel. So that's what we're going to have to use. And we could say that this angle right here, SPR, well, it's going to be congruent to angle QRP. I want to go ahead and put that down, and I want you to think about why. Right? Angle SPR is congruent to angle QRP. And why would that be? Hopefully, you remember, we have ourselves an alternate interior angles congruence. All right, so remember, everything that we've learned from chapters 1, 2, 3, 4, you are seeing the fact that we are using it again to help us put all this together. So now I got side, I've got an angle, and I've got a side. We've got 2 congruent triangles. So right here, number 4, triangle PQR is congruent to triangle RSP. And right here, we have our reason, side, angle, side. And there you have it. Now you're side angle, side experts. But that is not the only way to prove triangles, but it's the first one that we're covering. and you'll see many others as we finish off this chapter.